Let's look at the third problem. Uh, uh, this one. Let's read the problem. Tufan knows that Vault fast code contains n numbers to enter, with each number being an integer from 1 to k, and he found a scrap of paper that gives some information about the passcode. In particular, Tufan has with this array of length n where a is either 0 or an integer, and if it is equals to 0, then there is no information about the ith digit. The point is that it will open if either the correct code is entered or reverse of that correct code is entered. And basically he is trying to try every possible passcode that matches the information in lexicographical order. However, if he has already tried the reverse of a passcode, he will skip the passcode because he knows that world being faulty, and we have to find how many attempts must to find. Uh, let's understand the problem. Basically, we are given array, basically which contains digits from 1 to k, and sum of digits are equals to 0. So, and we have to find correct passcode by checking all the possible combinations. So in this question, what we can do is let's look at some of the example. Like their test kits are very good. Let's look at this one. Here one, let's wait, 1 0 0 and 2. So here you can place as value of k is equals to 7. I have 7 choices here and 7 choices here. So a total of 49 choices. 7 into 7, 49 choices. And if you look at this particular array, then there will no reverse pattern. Like if you as we know that this character is 1, then why I will change this to another character. I will, whenever I try combination, I will always put 1 here, and let's suppose I put here x and I put here y, and I know that I will put here 2. So there will not be any condition when the two combination we are trying to do is the reverse and are equal. Like uh, if we try to reverse this, then there will be 2 and both are not equal. So in this case the answer is 49 only. So and if it is like this, then we have some choices of for here, which is like if I have tried 1 2 3 1, then I can't try 1 3 2 and 1, because both the reverse of this is equals to the previous one. So we have to skip this, skip this one, skip this one. uh, so how to do this? We have to first look whether the reverse is possible or not. This is relatively easier to look if a of I and a of n minus I minus 1. Let's suppose I am taking 0 indexing. Is both are not equals to 0, and both are not equals to 0 and both are not equal, then there will never be any condition in which the combination we are trying are reverse of each other. So in this case we have to simply print the all the possible combination. Like we have simply the answer will be the number of zeros, raised to power like k raised to power number of zeros. So this will be answer in this case. But what if the uh, if it is possible to generate the reverse? So there are four cases. uh, a of I equals to 0 and a of n minus I minus 1 is equals to x, this case. And then the second one is basically this case 0 and x. Third one is like x, and fourth one is both are 0. Now in this case, uh, basically first we find the total number of uh, total maximum possible answer, which is basically equals to k raised to power number of zeros. Okay, and now if in this case if we are trying to make the reverse, and if like for the reverse to be possible, we must have a of I assigned to x. Let's look at this example, this one. If you take this example 40060 6 and 0, so let's take one combination 4 1 2 6 and 0. Now if you take the reverse, then I know I'll and here 3. Then I let's suppose I take like this one 6 and 1. Then you know that like you can never be the reverse of this will not exist, like because this is fixed, so the reverse of this is not possible. But what if I uh, use like something like 6 and something like here, let's suppose x, and then here 6 and then here 4. Then if you take the reverse, then it wait, let's take this example. So here you placed 1 and here 2, then the reverse is possible in this case. So we have to find this one. We have to encounter this case. So whenever this case arise 0 and x, then we know that the possible values of for ai is only x to be reverse, so reverse to exist. So in this case we have only one choice for choice for ai in this case, and similarly for this one also. And if in this case, like it is already assigned, and for this case we can have uh, now let's suppose we have fixed this one. Like we know we have sorted this part, and now we are left with only 0 and 0, like pairwise 0, something like that. Let's remove all the ai and a of n minus minus I minus 1, in which any value is not equals to 0. So finally the pattern will be something like that, and we have to count. Now the question is, we have to count the number of uh, now we have to find the answer for this pattern. If we are able to find the answer for this one, then the question is solved. So now how to do this? Basically, if you look at this, then let's take some example 3 2 and 1. So we have we don't have to count this combination. Now, how many choice do we have here? We have k raised to power n choices, like n is the number of zeros here, and we have to subtract these one 4321 type. So if you see that this is indeed equal to this is indeed equal to mm, basically for all the pattern there must exist a reverse. So total number of combinations is k raised to power n, so we have to divide it by 2. But uh, let's look at this one, 1 2 and 2 and 1. So for this reverse is equal, reverse is exactly the same, so this is over counted. So first we have to subtract this type of combination. So this one is equals to basically k raised to power n plus 1 by 2. We have to subtract all the palindrome from here and finally take divide by 2. So this is the answer for, and so basically this is equals to, this is the count of, we have to remove this one, like we this is the number of reverse that we need not to be count, so we have to subtract from the original answer. So let's look at the code. Here I have taken the input n and k and then vector and finally count. Count is basically counting the number of zeros. C1 is basically counting the number of pairs I and n minus I minus 1, corresponding pairs like. And so total answer is k raised to power count. This is a code for binary exponentiation. Here is the code for binary exponentiation, and this is the code for calculating mod inverse. We need this. And now first I am checking whether the reverse is the condition, the whether the reverse is possible or not. So if both are not equals to 0 and the value is not equals to the corresponding value on the other side, then I am mark, then it is not possible to create the reverse. So I'm, then the answer will be total answer in this case. And otherwise c1 k raised to power c1 minus k raised to power c1 plus 1 by 2, these are over counted, so I am subtracting and divide by 2, and I am subtracting it from the total answer and finally printing the answer. Hope you understand this.